Sketch the region bounded by y equals 1 over x squared, y equals x, and y equals x over 8, and find the area. Yes, this is confusing because there are lots of curves intersecting one another, so it might be helpful to draw pictures of each of the curves individually and then merge them together. So we're going to do y equals 1 over x squared, y equals x, and y equals x over 8. We're just going to go first quadrant, 2 units up, 2 units to the right in each of these pictures. Okay, let's just do ordered pairs. We'll make a table of x and y values. When x is equal to 0, y is equal to 1 over 0. Well, that's infinitely large, it's undefined. When x is equal to 1, y is 1. When it's 2, it's 1/4. When it's 3, it's 1/8. So graph this pattern. Here's 1, 1. Here's 2, 1/4. And it keeps getting closer and closer to infinity as it moves to the left, and it gets closer to the x-axis that moves to the right. Now y equals x, that's just a diagonal line that passes through the origin, 0, 0, 1, 1, 2, 2. So here's our picture of that one. And so that one was just a line. And y equals x over 8, that's a line with the slope 1 over 8, y-intercept at 0. So it's 0, 0, 1, 1/8, 2, 2/8, 3, 3/8. So let's graph that in the first quadrant. See, it's just a line. The second one was just a line. The first one was a curve. They're all curves, but this first one actually curved. The others are straight lines, so connect the points together with a straight line. And we get that picture. So we want to put all these pictures together and have them in the first quadrant so we can view the intersection and consider the region that's bounded by these. So find the points of intersection. It's not just an easy venture. We have to do it in 3 parts. Step A, let's set y equals 1 over x squared equal to y over x equals x and solve for x. That gives us 1 equals x cubed, which means x equals 1. Find the ordered pair. xy is 1, 1. You find the ordered pair by substituting x equals 1 into either of the 2 equations that you started with. Step B, set y equals 1 over x squared equal to y equals x over 8. Solve for x. So I multiply both sides by x squared, and then I get x cubed equals 8, so x equals 2. Plug that into, I don't know, y equals x over 8. You get 2 over 8, which is 1/4, so you have the ordered pair 2, 1/4. Okay, set y equals x equal to y equals x over 8 and solve for x. So x equals x over 8. Move them together on one side, x minus x over 8 equals 0. Get a common denominator, and you'll have 7x over 8 equals 0. Solve for x, you get x equals 0. Plug x equals 0 into either of the 2 equations that you started with and get the y partner, you get 0, 0. So we found 3 points of intersection, and we had the 3 graphs at the top, so we can put this all together in a single graph. I think you need to see this closely, so I'm going to try to zoom in on this portion here. I hope that's not too annoying. So here's the first quadrant. And let's sketch our points of intersection, 0, 0, 1, 1, and the last one was, what was that? 2 and 1, what was that? 1/8, 1/4, something like that. So we got this line and that curve, then the line, and then the other line at y equals x over 8. And you can see the points of intersection. So its boundaries to this triangular region. So we have y equals x, y equals 1 over x squared, and down below we have y equals x over 8. Now we're going to have to break this up into 2 regions because it's like the problem we saw earlier, region A1 and region A2. So we'll have to break up the integral from 0 to 1 and evaluate that integral, and then from 1 to 2. And the reason we have to do that is because we have different boundaries in each of those regions. We have a different upper and a different lower function for evaluating the integrals. So I'll let you take it from there. If you have any more questions, just come back and we'll take it further.